Welcome to this episode of the Shared Security Podcast. And joining me today is very special guest, Vivek Ramachandran, founder of SquareX. Welcome to the podcast, Vivek.
Thanks so much, Tom, for having me on the show, and super excited to speak with you.
Yes, I'm excited as well. And for our audience that doesn't know Vivek, well, I wanted to pull up some Wi-Fi security history here, as Vivek is the guy that introduced the world to the Cafe Latte man-in-the-middle attack back in the day. And maybe I'm dating myself here, but this was when WEP was the default method of securing Wi-Fi networks. So just wanted to bring that up because from a history perspective, you've done a lot with Wi-Fi security back in the day, right?
Yeah, I started my career, 2006, 2007. This was the time when security wasn't as mainstream as it is today. So it was very difficult to really find research labs where you could do meaningful work. And I got a very big break at this startup called Airtight doing wireless intrusion detection systems. And that is what led to, the Cafe Latte and a bunch of other attacks.
Yeah. It's just hard to believe that was so long ago, but it was so important to, I think, even Wi-Fi security today. It still is scary to think that, WEP was the only thing back then that we had to secure networks. It's pretty crazy. So You've also done a lot of work with, you were the founder and CEO of the Pentest Academy. And I know that was something that when I was starting my career as a pen tester, used as a resource. I know many others have as well. So that was just such a great resource. And I think many people are really thankful to you for having that resource in their careers.
Yeah, thanks, Tom. Really appreciate it. And I can tell you that was one of the most amazing experiences because when I started everything, I never realized how popular it would end up being. And even today, when I'm at conferences, random folks walk up to me and basically say, hey, Vivek, have used your stuff. And this helped me get a job or helped me hone a skill that I needed at the right time. So I think a lot of luck, but very thankful for the whole community for having used all of that and, making the company successful.
So kind of getting to today, talk to us about, you've done a lot of research, been in the industry for a while. What prompted you to start this new venture called SquareX?
So, as you pointed out, Pentest Academy, SecurityTube.net, I was actually doing research for well over a decade. And primarily in Pentester, our clients were red teams, pen testers, and all of you guys are always looking for new attack vectors so that you can show off within your organization or probably attack other organizations and probably win consulting contracts. So when doing that research, one of the recurring things that started coming was the fact that, now with hybrid work and, everybody having their own little laptop and being outside the confines of enterprises, the big thing was that how would attackers end up targeting employees, when they're on their laptops, when they're on the internet. So a lot of the initial access stuff was changing very fast. And that is when I realized that, hey, what about attacks which are completely client-side targeting employees within the company? And so, of course, when you're designing attacks, the first thing you look at is what security solutions are out there. And that was the time when I saw, you had secure web gateways, you had endpoint security. And I started figuring that there was this very big gaping hole in the fact that nothing was really looking inside the browser to actually figure out if there were attacks happening. And very soon, I was able to devise a lot of attacks which would completely bypass some of these existing security controls. So having been an attacker for, over 15 to 17 years, I kind of felt, and again, a lot of people would probably hate me for saying this, is attacks are easier to orchestrate compared to defenses because the defender has to win every single time, the attacker only has to win once. And having done that for a while, I said, hey, why not, kind of go ahead, change my hats a little bit, go on the other side and see how it feels like. So that was really the inception of SquareX, which is, could we build a browser security product which can protect employees from client-side attacks? And that's how the company, came to be.
So can you talk a little bit about just the basics of how SquareX works and how it protects users online?
Yeah, that's a great question. So Tom, if you think about it, all of us use a variety of different browsers. We all have our favorites, Chrome, Edge. I don't know if anyone has Edge as a favorite, but let's say they do.
A few people do, maybe.
Firefox, Safari, and whatnot. And this is really where employees tend to spend 90% of the time in the browser, but enterprises don't have any security controls. So the way SquareX ends up working is, the first thing we said is, look, we have to work with any browser. Now, people were using proxies as a way to send all the traffic, to the network side. But the downside of that is the fact that, you are trying to look at network traffic to infer application layer attacks. And one can already see how stupid that was. So that is really where we wanted SquareX to be sitting at the place where the events were happening in real time, where user interaction was happening in real time, and where attacks finally were being orchestrated. So that key realization led us to believe that we have to reside in the browser. Now, of course, one way out would have been that we would have just modified browsers and given our own browser up to you. The tricky part is, we've seen with the Brave story and a bunch of other browsers that never works. So that's really where we said, could we build a browser extension which could actually go ahead, sit there, monitor DOM events, monitor browser events, look at user interactivity, and literally have the ability to run detection models, rule policy enforcement, ML algorithms, all of that in the browser as a lightweight way to go ahead and do detection. Now, the tricky part really is, the browser is really not an application framework on which you're building applications, right? It is not the cloud where people have given you a bunch of very productive APIs. So when we started researching, there was a lot of tribal knowledge that we ended up uncovering. Quirks that we found in the browser's rendering engine, hooking engines, and all of that. And, one thing led to the other, and things like WebAssembly, which is a great way to run native code on browsers, was something, which has been receiving a lot of tailwind in the last few years. And all of that together allowed us to create an in-browser security product, which can be deployed as a very simple browser extension on any browser. And, with no endpoint security agent to be installed. I know how much people hate doing that. And that is really how SquareX's, product works. Sits in the browser, looks at events, runs detection algorithms, reports back to the mothership, shows admins what's going on.
Yeah, I love that it's integrated into the web browser because, like you said, everybody uses a web browser at work. And it's especially during the pandemic, more companies were moving things into the cloud. So the browser became even more important to people. So I truly love the solution that SquareX has put together. You mentioned secure web gateways, and I wanted to talk about that for a minute because that seems to be all the rage in enterprise security these days. What are your thoughts? Are secure web gateways really effective against a, determined attacker, or do you think they've kind of become obsolete?
Yeah, no, again, great question. And if you look at the genesis of secure web gateways, we probably have to go back to the world of early proxies. And that was the time when, SSL was starting to be more pervasive and people needed a way to monitor traffic. So the promise that SWGs or secure web gateways came with is the fact that, you don't need any on-prem security products. Just ship us all the traffic. And in the cloud, we will decrypt SSL, look at the HTML, CSS, and JavaScript and clean everything up for you. We're going to block malware from getting downloaded. Hey, admin, you don't even need to worry about anything. You don't need to learn new security products, none of that, right? And that's a great promise because managing all of these disparate products on-prem required, people who would be well trained, required, around the clock monitoring and whatnot. Now, Tom, if you go back 10 years, you would actually find that web applications were pretty simple back then. HTML, CSS, JavaScript, right? Then, Web 2.0 and all of that started catching fire. Gmail came with this very responsive application where you didn't have to refresh the page again and again, which is really what we used to do back in the day.
Yeah.
And now if you look at it, web apps are very complex, API driven, and literally where you have, very thin JavaScript based clients which work in a very iterative way, getting new data and changing the UI all the time. So unfortunately, web gateways are looking at network traffic with no clue about how all of that HTML, CSS, and JavaScript is used by the browser's rendering engine to create an user interface. It has no clue about how the user interacts with it. I'll give you very simple examples, right? Imagine you have 10 browser tabs open, and in one of the tabs which is inactive, all of a sudden there is a file download which happens. And maybe this is, a website with a malicious add JavaScript which suddenly does, a dropper. Now, a secure web gateway has no clue whether Tom actually clicked on a link where this download is happening, or that this does happen in an asynchronous way. I'll give you another example. There are sites which read clipboards. Now, this is really where when clipboard data is sent, an SWG has no clue whether this is clipboard data, a form submission, session data, or just gibberish. So the lack of application context is the number one issue with SWGs. The second issue, which I think is also big enough, is they use URLs as a core construct to whitelist everything. Which means today, an admin ends up whitelisting GitHub, then all repos, which even a malicious actor could create and zip up malware and put in there, are automatically whitelisted. So I think if you look at things like zero trust, you need to be able to look at every component loading on the web page and try to do an independent analysis on its security posture rather than whitelist the whole thing just because it loaded from a website. So I could go on and on, but all of this as a domino effect, unfortunately makes SWGs very difficult to use when it comes to detecting attacks. And we are actually doing a very big talk, main stage 1 at DEFCON this year, where we will actually demonstrate this against, all popular SWGs in the Gartner quadrant.
Oh, that's awesome. Kind of speaking of that, how big is the secure web gateway industry? Like, who are the key players nowadays?
Yeah, so I think, secure web gateway started off as an independent industry, but now is part of SASE and SSE offerings. And the world's biggest cybersecurity companies, that you can think of are part of this industry. Palo Alto Networks, Netscope, Cisco Umbrella, Zscaler, I would say, a bunch of other players as well. Everybody has something or the other when it comes to intercepting proxies. And that's really where, these are pretty much deployed in the largest organizations you can think of today as a measure to protect web traffic.
Yeah, you had mentioned your DEFCON talk. Can you talk a little bit about some of the attacks that you're going to be demonstrating at the conference?
Yeah. I mean, I'll give you, and your audience a very sneak preview understanding, of course,
excellent.
or else, I don't want DEFCON to pull down my talk saying, you told everything.
No. Don't want that.
So, the talk we are giving is around architecture of secure web gateways and what is fundamentally broken in them. And just to give you a high-level view, the tricky part really is if an attacker can smuggle his code through a secure web gateway and finally have an end machine where he can reassemble and run code, then he can easily evade SWGs. And that end machine is really your web browser, because a web browser is an execution platform, not just a viewing platform. And that is the core premise of how all these attacks are being concocted. The second part that I want to mention is known limitations. You won't even believe some of the largest companies that can you guess the maximum file size that they can actually check in the cloud for malware? What do you think is a reasonable size today? Couple of 100 megabits probably?
Yeah, I would say so, yeah.
One of the largest providers, their limit is 15 MB. So if there is so if there is a file size more than 15 megs, the admin has to either create a blanket allow or a blanket block policy. There is no other option.
Oh boy.
Many of these gateways, unfortunately, cannot look at zip files. Or even if they can look at zip files, they kind of time out after 1 or 2 orders of recursion, which is an attacker could take a piece of malware, zip it 4 times, and most proxies can't look beyond like 2 zips. Now, why are all of these limitations, right? Because end of the day, SWG vendors, of course, want all of this to be profitable. And now imagine that you are burdened with, analyzing millions of requests per second. And how much time can you really devote on a per file, on a per request basis? Because if you're going to take a couple of seconds, that's massive amount of compute and memory that you're spending per file. So the tricky part is at some point, I think, purely because of economy of how the whole thing has to work, you can only spend a fraction of time on any given sample, and you need to be very quick in deciding because A, you don't want high latency, and B, of course, you don't want to spend so much time that you end up going ahead and burning a lot of your own compute power, which makes this model economically unviable. Now, solutions which sit in the browser, the good news is you probably have 15 tabs open, out of which there's probably 14 of them are inactive, and the browser slowly puts them to sleep. So the workload is actually a lot less than one imagines, making it a lot more easier to do deep inspection. And that's how I would kind of compare a cloud-based security solution versus a browser-native one.
Kind of taking all that into consideration, like what is your recommendation then for enterprises that are trying to protect themselves against web attacks?
So I think, two parts to the answer. One is attacks which I kind of call originate, and the whole life cycle of the attack is within the browser itself. And I'll give you examples. Let's say credential stealers. For a very long time, these used to be, binaries that you end up downloading, get installed, start stealing stuff and send to the mothership. You won't believe what is the simplest credential stealer today. Now, everyone wants to go ahead and, install AI co-pilots, right?
Yes.
And when, OpenAI comes up with a new ChatGPT model, no one wants to pay for it. So this is really where, have you seen all of those ads where they basically say an AI co-pilot better than ChatGPT, something you probably don't know exists, right? Yeah. Now, unbelievably, Tom, many of them actually will lead you to a browser extension install, which in the backend ends up using GPT-4. But when you install that browser extension, it's actually stealing your session data, stealing credentials as you type them, and it is sending all of those back to the attacker. Now, unfortunately today, most enterprises absolutely have no way to look at many of these things. So to enterprises, the tricky part today is all of these web attacks, unfortunately, you will require a browser security agent. Additionally, I think attacks which start from the web and finally end up on the local system, as an example, download of a piece of malware, that is really where you need good endpoint security protection and isolation technologies. So I think the defense in depth, building, defense in multiple layers is kind of like super important. And that's the way I would look at it. My 2 cents is I feel like once we put out the attacks, you will actually see that almost every single known attack vector which SWGs promised, as an example, known malware, will completely kind of like pass through, and you will require something in the browser.
So last question, I love asking this question to everyone I've been interviewing recently. What are your thoughts on AI and attackers actually using it? Because there's been a lot of research coming out that attackers really aren't using it. Maybe the script kiddies are, but there isn't like a lot going on there. What are your thoughts? Do you think it's going to eventually get worse there?
Yeah, that's a great question. And I think, I feel a lot of security vendors, probably even CISOs, love to downplay the role of AI. Is simply because, of course, no vendor wants to say that AI is now supercharging attacks. Now, here's the way I look at it, right? My background, most of my team's background is actually attack research. And you won't believe, like most of the attacks that now we are going to demonstrate, including the ones at DEFCON, we literally used prompts and had AI write it out. So the big force multiplier that attackers have today is previously what used to happen is you used to read about a vulnerability. And most attackers, without the light level of expertise, would have to wait for some Uber hacker to finally release a tool which they could just start running. But now, literally, Tom, there are papers on how you could just feed in CV information along with the source code of the, program being attacked, and AI starts to generate all of those combinations. I feel it is very real. So here is what is going to happen. I think I would look at AI attackers' perspective two-pronged. The first is the time between a new attack getting publicly discovered and disclosed to attack tools being, available. That period is going to shorten by a very crazy amount. Because now if you're great at prompt engineering, you could go ahead and use existing code LLM models to do that in a very fast way. The second thing what is going to happen, which is already happening, is I think for a very long time, end users, including technical users, have used their sensibilities and their senses to decide whether something is a fake persona or not. So now with deep fakes where people's voice are being mimicked, their videos are being mimicked and all of that, I think we no longer can rely on what we hear or what we see as something we previously used as filters. So the tricky part, what's going to happen is, I think end user based attacks are going to explode, fraud is going to explode, and this is going to disproportionately go ahead and affect both enterprise users as well as consumer users. Simply because, look, an enterprise user is just a consumer shrink trapped with an enterprise, wear, nothing more, right? So I feel an entire new class of attacks will come and an entire new class of products will have to be envisioned.
I completely agree. I think we're just on the cusp of all of that happening. And I think there will be events like the election in the US here that are going to expedite some of that, right? Like we've already seen a lot of concerns about deepfakes and how social media is now being leveraged with AI tools to manipulate people's viewpoints. And I think it's going to be very interesting. And I think you're spot on with your predictions. We're just about to see what's going to happen.
Yeah. I mean, sadly, things are going to get worse before they get better. And I think the best thing to do is, as you rightly said, to acknowledge that rather than fight it.
That's right. That's right. Well, Vivek, this has been an absolute pleasure having you on the podcast. How can our listeners find out more about you and SquareX?
So, thanks so much, Tom. It was a pleasure. Great talking. So I think, if the listeners are interested, I think they can connect to me on LinkedIn, Vivek Ramachandran. On Twitter, I am VIVRAMAC, Viv Ramac. And SquareX, I think SQRX.com, our website, is the definitive place. We have blog articles, links to our social media accounts, and we try our best to post the latest and greatest, as often as we can. So those would be great places. And thank you so much for listening.
Well, again, thank you very much. We'll be connecting again here, hopefully at Black Hat, and looking forward to speaking with you again.
Likewise. Thanks so much for having me, Tom.
Thanks for watching or listening to this episode. Be sure to subscribe wherever you like to listen to podcasts, follow us on X at SharedSec, and help support the podcast by joining our Patreon to get ad-free episodes, bonus content, and many more exclusive supporter-only benefits. Visit sharedsecurity.net/supporter for more details.